Okay, so part 3 of this video talks about 1.6. And in problems 1.6, you're taking polynomial, or I guess just functions, and using them to model certain situations. It doesn't, they just basically use some geometric ideas to use the functions, but not really sure if it's realistic, maybe to say. They're not really maybe appropriate connections that they can make with the functions, but anyway, that's what they do. So like I said, we won't have much on there, if anything at all, regarding 1.6, because you'll see some of the problems there are a little tricky. So I'm just going to do a couple little examples here. The second one I'm going to do is a little more involving, and you use something called GeoGebra for that. But if I start out with, there's a couple of problems in the homework that start off with, say you have a pen. You're going to make a pen for a dog. Maybe it's a puppy. All right. And this problem is one that's been used many times. It's something you probably have already seen before. All right, so we're going to make a pen for a puppy, and we want it to be rectangular. Okay, and what we have is we have a fixed perimeter. All right, and when we fix our perimeter, that also means we're fixing our costs. Okay. All right. So what we want to do is build the rectangle that maximizes the area. All right, so we want to find the rectangular shape that's going to maximize the area. Okay, so again, this is something you probably have seen before. So if we have, say, a pen that is 60 feet in perimeter, okay, so something like this, right? And we know the perimeter is this distance around, all right, and that's 60. But we want to change, and we want to take and maximize the area of that rectangle. All right, we want to find what shape is or what dimensions is going to give me the most area. And a lot of times in mathematics, this is a good example, because when you're applying it in certain situations, you're always looking to find something that is the most efficient, right, or is going to cost the least but provide the most. My neighbor, for example, lives next door, works on a sales company that produces. So as I was saying, this neighbor of mine works in sales and they do production equipment, and they're always looking for the most they can make packaging wise. That's what they do. They sell packaging equipment, so they're always looking to maximize the number of items they can package in the least amount of time. So in mathematics, we're always, in application wise anyway, a lot of times you're trying to take a situation and maximize something while you're making it the most efficient or minimizing the cost. So in this case, back to this problem here, we have this 60-foot perimeter pen that we're going to make. So let's call this dimension down here x, since we're not sure what that is. And we know that in a rectangle, that's obviously going to be the same. Okay. So here, then, for these other dimensions, we don't want to use y. We want to keep it in terms of x. All right. And we have this 60-foot perimeter that goes around there. So we could have 60 feet here. All right. And that makes up two of these x's. So then for these two on the side here, here and here, right, I have 60 feet minus the 2x's that I used for, say, the lengths. That's what those might be, all right? And that has to be shared with 2. So that means that this dimension would look like this, right? And you could simplify that, certainly, because 2 goes into both of those things. And it would look something like that, okay? Well, we can find the area of this rectangle by simply writing the area formula. So base times height, or length times width. So x times 30 minus x. And for those who just have to have it this way, there we go. So now we can say, well, we're going to set that, we want to maximize that area, right? So we're going to graph that and see what it looks like. All right, so let's go into Desmos, and we'll go ahead and graph this. So let's see, we have, again, I'm just going to put the y equals in there. Come on. There we go. Y equals, I think it was, what do we have, 30x minus x squared. So there's what we have. And in this situation, you can't really see much, right? So you need to change your viewing rectangle. And this again comes into the idea that, well, I can't really see what's going on here, but we're going to change the domain of this and the range so that it fits the situation, right? So our domain, for example, we know we're not going to have anything less than 0 for that length, right? So let's go into the tools here, and let's make our x-axis minimum value 0, right? Now, our maximum value, if we think about that, right, we have 60 amount of perimeter, right? So obviously, we can't exceed 60. And really, you can see that it hits down here at 30. And that makes sense because we couldn't share both, right? So let's just say we'll put it as 30. But I'm just going to add just a tad bit so that I have both of those things. Okay. Now, of course, I forgot to do anything with the range. So let me go back and do something with that. Again, that's your area. All right. So then we know that that's not going to ever be a negative number. And here we don't know what that maximum number is, right? But I do know that I'm not going to exceed something that would be 30 times 30 because that isn't going to fit. So I'm just going to put 900 in here, and I can see that I hit the bottom of that, so I don't need to have 900. So maybe I can go 500, and that's a pretty good idea. Now I can play with this a little bit and get it so that I want it. So there is my parabola that describes this area, and that's what we would anticipate, right? Because it's an x squared, and we talked about that last week, how that even of squares gives us those U shapes or up-down U shapes. So to find that maximum, I'm going to tap on that, and I get 15 and 225. So now I know that my x value that gives the largest area has got to be 15. All right. And for most of you probably know that if this is my x value, let's go ahead and see what the other one's going to be. And we have a 15 by 15 shape, which is a square. And of course, a square is going to give you the maximum amount of area for a rectangle. All right. We may not think about it. When we think about rectangles, we think of this type of a rectangle like I drew, not necessarily the fact that it could be a square. All right. And with more investigation, we find out that if we really want the most efficient shape, we choose a circle. Okay, you're always going to get more area from a circle with a fixed perimeter than you would any other shape. So that's that problem there. Now, what I want to do is show you a different example because this is kind of what you're going to see in a couple of the homework problems, okay, but not to this extent. So we're going to go ahead and get into go to your PCC here, and I'm checking this out as I go along also with you. Okay, so I'm going to access into that. Okay, I want to go to my courses. Alright, so here's where we are. Alright, and we're going to go into this course here. Alright, and here's where everything is, and you guys have accessed this hopefully already. Okay, so as you can see, I put in the lesson video from Wednesday. Alright, but we're interested in the materials. That's where we want to go. And I put this in the other day, so I'm hoping that it works. So I have there's my solutions for the test right there. There's my review. Here's the syllabus, but we want this cylinder link here. Alright, now this is a GeoGebra application here, and it has a couple different things. It has a GeoGebra has a geometry application, it has an algebra application, and it has a spreadsheet application. So I have a lot of stuff here. And in this problem, what we're doing is we're going to take a cylinder and we're going to fix that surface area. So again, it's coming down to a production, right? So if we have some sort of a cylinder that we're going to make and we have a certain amount of material that we can make it from, but we want to fix that, and we want it to have so our cost stays the same, but we want to maximize the volume. All right, so here's my cylinder, okay, and right here, oops, that was not good. This thing is very, very touchy, so it might not work very well. You can see what happened there if I just point to it with my pen. So there's my cylinder, all right, and what we're going to do is we're going to take this thing over here, which is a slider, and on your computer, go ahead and slide that, and what will happen is it will collect data. Now I'm going to try sliding it with my okay, and hopefully I've collected enough data. It kind of looks like I did. Okay, so I have enough data here. Hopefully this worked. It might have worked a little differently for you. Okay, so I noticed that it wasn't quite working correctly, and I think that's again, this is just on the Surface Pro. It doesn't work. GeoGebra doesn't work as well, but I tried to change the radius because the radius cannot be 10. It doesn't fit the situation. It bottoms out at about 6 or 7. All right, so I think it's actually 6.4. So these numbers down in here are not part of the situation. Okay, so what we're going to do then is go ahead and let's see if I can get it to just collect well, I'm just going to leave it. So hopefully on yours, I know it's going to work much better, and you're going to have a much better data set here. All right, so what we're trying to do is maximize the volume. All right, so we've got all this situation here. What we're going to do is we're going to select these numbers, and this is where it's going to get difficult for me. I'm going to go right to there, and I don't know if I'm going to get it to work. I hope I can. But I have to, once you get these numbers selected, you're going to right click. Okay, so we're going to, man. I'm just going to have to walk you through it. You're going to right click on, once you get the numbers from all the way down to about 6.4, okay? Highlight those, select both columns from right down to 6.4, then do a right click. And when you do a right click, okay, what's going to happen is that you'll get create, and you want to make a list of points, okay? And it will give you that option. It's just like I said, it doesn't work very well on my Surface Pro. Okay, so you'll go right click, create a list of points. Now over here, you can make this thing a little bit, let's make this algebra window a little bit smaller, and you should be able to grab and do that. Okay, I can't, but you can. Alright, so it won't let me do it. But you can make that a little bit smaller. When you do, you're going to get a list of points. You're going to see the points over here on this screen. Alright, so make that smaller. Make this screen smaller by just grabbing it and dragging it over. Maybe the sub can show you how to do that. Okay, you're going to grab that, make that over. So you're going to have a nice graph screen there. Okay, if you hold down and do another right click just someplace on the screen here where you have those points shown, then you're going to get option for showing axes. And so click on that. And now if you play around with your window there enough, right, you should get a nice graph of those points. Okay, so what I'm going to try to do is put those points into here. Let me pause this and see what I can do. Okay, so now what I'm doing is I'm videoing it on here. So once you make these things different sizes here and here, then you can get this axis here, and at some point my list of points, there they are going to start showing up here. Okay, but I want to change the dimensions on the y-axis, so I'm just going to do a right click on that. I don't know if I'll be able to, but here we go. So if you change your dimensions just right, which I'm not getting a right click there. So if you right click on this, you can change your dimensions, and right click on this, you can change your dimensions so that you get a nice curve. Okay, and these points are going to be better. So we're looking at the A1, the B's, and those ones there, and I wish we could get a better. So I want to kind of spread this out and shrink this down. So I'm going to try to do it. So there's a 6 there, but we just need to make this. I don't know if we can get it, but if you right click on it, you'll be able to do it. Okay. All right. Anyway, so that's that. Now let's go back to here. Okay, and talk about this situation here. Okay, so we have a cylinder, and we fixed that surface area. So let's say we have a situation where we have, I think that was a fixed surface area of 200. All right. So, and what I'm trying to do again is find that maximum volume, right? So, the surface area formula for a cylinder is this. We're going to fix that at 200, much like we did the perimeter of the other thing. I'm going to divide everything by 2 to clear that out. All right, and now I'm going to leave that alone. Let's come over and talk about volume. Pi r squared h. So I have two variables. So just like I did before, I need to solve one of the variables, get in terms of r, okay? Because r is the radius, and that's what I slid up and down. So what I'm going to do then is figure out what h is. So I have to come over here and figure out what h is in terms of r, right? So let's do that. So here we can get rid of the pi's also. Like that. So it's getting a little bit simpler. Then what I'm going to do is I can also take this and get rid of one of the r's, right? And I could have factored that out too. I could have factored an r out and then divided it over. So now I have this, all right, and then by simply just subtracting that, we have what h is. So once we do that part, and this would be kind of what the assignment problems are going to do. They're going to give you a situation like this. You're not going to have to do any of the GeoGebra stuff for it. I was just kind of embellishing it a little bit. So now we have volume, pi r squared h. So here, and h is right here. Okay, and there is my formula for that. All right, so then if I go back into Desmos, I could go ahead and graph this and find out where that maximum is. And we could look at the table, the spreadsheet compared, and we could come up with a pretty good idea if that was correct. All right, so let's go ahead and do that. I'm going to go here in the Desmos, and I'm going to clear that out, and let's type this in. So let's see, we've got, go back and look at it. I have pi r squared, and I want to use x, right? Oops, I like to do this. All right, and then I have parentheses 100 divided by and minus that x. Okay, so I have this. All right. Oh, look at that. Definitely you should recognize that graph as being a cubic, right? A power function, odd degree. Okay, if I tap on the top here to find my maximum, 3.257 would be the radius that's going to give me the maximum amount of volume. If we go back into the GeoGebra thing, I'm betting that that's probably, let's see if it will take me back to it. So here we're at 217. That was our maximum, because remember these ones didn't work. So notice that was about 3.2. And we could have did it all in GeoGebra. If on the computer, it would have worked out all right. But on my tablet, it doesn't work as well. So anyway, that's how that works. So let's get you some problems set up to work on here. And so let's do some of these. On 97, try these ones out. And then do one of these on that page. Okay, so those are some ones you can try, work on those, and then we'll go over them. You guys can just kind of work together on that part, and then you'll be taking your quiz, and then you should be all set. So again, email me if you have any questions on anything, and I'll see you on Monday.